Okay, this example relates to selecting an optimal portfolio of assets. Now, an optimal portfolio of assets is one which gives you a certain expected return, but for a minimal risk. Now, return is good, risk is bad. So you don't want to set up a portfolio which has higher than average risk. If you can get the same return for a lower risk, you always want to set a portfolio up in that way. Now, setting up a spreadsheet to do this is quite complicated, and so there's detailed notes in topic 10 on how to do that, and you can see that down the bottom there. Okay, it's all there. And there are many examples on the blackboard which will help you do this as well, and you're going to have to do a tutorial question during this, and so it will take you some time. You need to know about how matrix algebra works, how Excel works, and you need to have, in particular, use the solver to do that. Now, if I look at, there's a simple example, and then there's this one here, 8C. So we might just go straight to 8C. Now, again, I can't really go through step by step. It'll take me an hour or two to do this, but you'll have to do that yourselves. But here's an example. We've got, what have we got? 6 different shares. We've got ANZ, we've got BHP, etc., etc. And these are these are returns, actually. These are returns. And then what you've got to do is you've got to find the expected return for each share, and that of course is just the average. Now these things here are all monthly, so what we've done is we've converted the monthly expected returns into annual by multiplying the all of them through by 12, and these are the shares. We then use matrix commands to transpose that. Okay, so that's transposed, and also we insert and define the name. So this is this matrix, or I suppose it's a column vector to be more precise, is called return, or RET, or return. We also need, so this gives us returns. We also need to find the riskiness, and to do that you need to use the variance and covariance command, which you can do. And this is the variance covariance matrix. So down the main diagonal gives you the variance of each return. There, 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 and there for each of the returns, and in the off diagonals you've got the covariances. Again, we convert these to annual variances and covariances by multiplying by 12. You can see up the top here it's multiplied by 12, and so therefore that's what we have. Now, weights. Now, one of the things I would always do when I set this spreadsheet up is I would make this weight 1 and the other weights 0, because what I'm saying here is I'm allocating all of my portfolio to ANZ. Now, if I'm allocating all of my portfolio to ANZ, when I use these things to work out the expected return on the portfolio, here it says it's 11.9% or 0.119. Now that should be, if I've done it right, ANZ's expected return, because my portfolio is set up so that I am holding ANZ and nothing else, and that's working. And the other thing it should be doing is, when I've worked out down the bottom here, portfolio risk, which is done here, or portfolio variance, 0.071, and again, if I've done that correctly, it should be ANZ's, and lo and behold it is. Okay. Now just to test that I'm still doing the right thing, perhaps I'll make BHP the only thing I'm holding. So I make that 0 and make that. Now once I've done that, if I'm doing it all correct, my portfolio return and risk should be BHP only, so 21.3% or 0.213. Let's have a look. BHP, annual returns, 21.3, BHP risk or variance, 0.061, so hopefully that's what we've got down the bottom there. And beautiful, we do. Okay, so it looks like we've now got a functioning spreadsheet to work out the risk and return of a portfolio of those 6 different assets. What we of course want is we want to set up a portfolio that gives us a certain return for the lowest possible level of risk. How do we do that? We use the solver, as we've been using all course. So click on solver, and this says here, portfolio risk. Set the portfolio risk to the minimum value by changing the weights WTS. Let's have a return, an expected return of 5%. That makes sure that the portfolio sum, the weights of the portfolio sum to 1, and we do not want to have any negative returns. It doesn't make sense to look for, negative weights. Negative weights doesn't make sense. So let's look what happens. See over here what we've got. We've got portfolio risk and return. All right. So we want a portfolio that gives us a 5% return for the lowest possible risk, and we click solve, and it works. And we now have a portfolio return of 5%, a risk of this, and you can see if you look at how the weights work, this is the way it's done. It's allocating nothing to ANZ, 29% to BDS, nothing to BHP, nothing to BIL, 70-odd% to CNG. Now, we can do this for many different expected returns. We save the results, and then we graph them, and we end up with this graph here, which is the efficient frontier. Now, the efficient frontier tells us about the series of efficient portfolios, or the risk and return of the efficient portfolios. Now, obviously, that means over here, as we're going up, it makes no sense to stay down here because, of course, if you're down here, you can get the same level of risk, say 20%, for a higher expected return. Now, up here, when you're moving in this direction here, you're trading off risk and return. So you're getting a higher return, but you're copying higher risk for it. Okay, now this is just an example of how you can set the thing up. Your tutorials will require you doing this with some actual real data, so you'll need to do that as well.